Hi, Calculus kids. This is Dr. Callahan with Week 3 Tuesday. How are you guys doing? I hope you had a wonderful 3-day weekend. Go ahead and pause the video and answer the following 3 questions on your warm-up block. Okay, let's go ahead and create the assignment for Week 3 Tuesday. We'll come back to hyperlearning again, but for those of you guys who are doing 50-50 learning in person, we're going to continue on with the assignments. So every day I will post assignment here. If you are supposed to be at home, just make sure you guys view the assignment for your attendance. But in addition to that, if you want the grade for that day, you need to make sure you upload your assignments onto the assignment tab. So that way you guys get your 10 points. So just keep that in mind. And for those of you guys who are seeing me in person every day, you don't have to worry about the attendance because I will see you in person. So that resolves that issue. So this is Week 3 Tuesday. Semester 2. And today we're going to talk about integral using average value theorem. And of course, as always, your instruction is very simple. Make sure you guys go ahead and watch the video. Make sure you copy it down with your guided notes and upload the assignment if you need it. Okay, so usually I update your grade on Mondays. Since Monday was an off day, your grades will be updated probably by Wednesday of this week. So I'll make sure that gets done. So this is for Week 3, Tuesday. The 2 links that you need for this class is going to be your YouTube channel, but also your Google Doc. We're no longer following the distance learning model. So I will have hard copies outside if you need to pick up. It's available for you to pick up outside of V1. And these are the 2 links that you need. 10 points. And as always, it's due the same day, 3 p.m. And I'll go ahead and hit this line. Okay, so today your guided notes is actually several pages. I'm going to go ahead and attach it as a extra PDF. So that way, if you want to print it out at home, you're able to. It is 7 pages. So here's your first page. This is my notes on today's examples. And also the guidelines for using fundamental theorem of calculus with absolute values, in addition to any theorems and formulas that you need for today's lesson. And so my notes extend to 2 different pages. There are 6 different examples here. And it also kind of summarizes like the second fundamental theorem of calculus with a definite integral, which we already talked about, but this just kind of summarizes it in a more succinct way, and everything is in order. This is your page 3. And again, it goes over the definite integral properties of from A to B and how you can manipulate that from A to B to A with a negative, etc., that we talked about previously. Page 4, page 5, I have some examples here with the steps. Page 6 is going to be your guided notes for class today, so make sure you have this. Page 7 with additional practices, and this is what you have. So I'm going to go ahead and save this and then attach it to the PDF so that way you have that available as well. Okay, save as. And we want to save this under calculus. I know this is week 3 Tuesday, but I actually have this under week 3 Monday. And I put an absolute value and integration absolute value. Okay, and let's do this as a PDF so that way it's available for everyone to access. Perfect. And let me move over here to the, okay, so you can see your assignment right now for week 3 Tuesday, and I want to make sure I attach that. Perfect. Here we go. All right, so here you go. Everything is set up perfectly. Awesome. So let's go back to your assignment. So let's go over some of the questions here, okay? So for your first question, it is talking about evaluating this absolute value with a definite integral. First thing you want to do is you kind of want to have an idea as to what this looks like. You know that when you have an absolute value, okay, there we go. When y equals the absolute value of x, you know that its shape is like a V shape, right? So we want to have a more generalized idea as to how this is going to look. So let's go ahead and maybe create a table of content. And you know your definite integrals from 0 to 2. So maybe let's start off with 0. So if x equals 0, you have 2 times 0 minus 1, which is -1, but the absolute value of 1 is a positive 1. Well, what about when x equals 1? 2 times 1 is 2, minus 1 is a 1, so it's still a 1. Then what about a 2? 2 times 2 is a 4, minus 1 is a 3. What about 3? 3 times 2 is a 6, 6 minus 1 is a 5. So you have 4 points right here. And I'm going to take those points and I'm going to plot it. And let's start off with 0, 1. So at 0, it started out 1. So there's my first point. 1, 1. And then 2, 3. 1, 2, 3. And then 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. Okay, so I kind of see where this is going. Let's see, 2, it is 3. Let's see, so 2 times 2 is 4 minus 3. So then if you could go ahead and graph this, you can see that it's going in this direction. And then of course there's like a space here. So maybe if I were to do like a 0.5, let's see where 0.5 will be at. If I do a 0.5, 2 times 0.5 is 1. 1 minus 1 is a 0. So that's kind of where I wanted right there. So I can see where that end of the V is, where the vertex is. So here's my vertex to my absolute value at 1/2, 0. And then it's probably just going to keep going. I mean, if you want to get a little bit more, you can do like a -1. -1 times 2 is a -2. Minus 1 is a -3. So 3, -1, 1, 2, 3. So you kind of see like where it's going. There you go. Now you're not going to be using the area of this entire V shape. You're only going to be using from 0 to 2. So 0 is like right here. And then 2 is 1, 2 right there. So I'm only concerned with this area that I'm highlighting in green. And there are 2 triangles right there if you take a look at that. All right, so your triangle 1, I'm going to label that triangle 1, triangle 2. With your triangle 1, it is a teeny tiny little triangle right here. and you need the base. Well, I know from 0 to 1/2, that's going to be my base, so 1/2. And I also need to know what my height is. Now, for your height, it's from 0 to 1, so my height is going to be 1. So my triangle 1 is area is 1/2 base times height. So then it's just going to be 1/4. That's your area for triangle 1. Now let's take a look at triangle number 2. For triangle number 2, my base is going to be from 1/2 to 1, so 1.5. And my height, it kind of looks like it's at 2, maybe a little bit over 2, or maybe at 3. If you're not sure, just remember that your f of x is equal to the absolute value of 2x minus 1. Okay, so then if I want my base to be at 1.5, then what is my height going to be? I'm sorry, if my if my x is going to be at 2, what is my height going to be? Because remember, this is at 2 for x. So f of 2 equals 2 times 2 is 4 minus 1. So my height actually is going to be at 3. So 1/2 base, that's 1.5, times height, which is 3. And I'm going to change that 1.5 back to a fraction so that we're consistent. And then 1 times 2 times 3, so that's going to give me a 9/4. All right, so then I have the two areas. I'm going to add them together. And it's 10/4 or 5/2. And that is my answer. Unit squared. There you go. All right, so let's go ahead and move forward. Last time I saw you guys, we did some practices with drawing graphs and finding the areas from a graph. And then I had you guys practice with this with the guided notes textbook practice from the video. And you had a link right here for the video right here. And I kind of want to go over a few of them that I thought were good ones to review on. So let's go ahead and take a look at number 40. Okay, so you're finding an integral from 2 to 4, and you don't have to do the integral of this if that's given to you what the area is, but you will have to use the properties of integral to kind of manipulate it back and forth a little bit. So I'm going to do the integral of 2 to 4, 6x, or excuse me, 6, we're just going to separate them, dx. So that's the first part right here, plus the integral of 2 to 4, 2x dx. And the last part, integral of 2 to 4, negative x a third dx. All right, so the first part that's given to me, integral of 6 dx. I could go ahead and move that 6 outside. So I have a 6 integral 2 to the 4 dx. And if I look at that right here, I know that the integral of 4 to 2 dx is equal to, and it looks like I kind of cut this part out. I'm sorry. It's actually equal to 2, so sorry about that. So then here, what that's going to be, because if I match this with this, it is going to be 2. So I'm left with 6 times 2, and that's my first part. Second part, what can I take out? I know that integral of 2 to 4 of x dx is equal to 6. So I'm going to put the 2 right here, 2 to 4, 2 to 4, x dx. So that's going to be a 2 times 6. Here I have a minus. I'm going to move that minus over to the outside. Integral, I keep putting 4. I don't know why I'm doing that. 2 to 4, x to the third dx. And you can see that because this piece right here matches this right here, which is 60. So minus 60. So I have 12 plus 12 minus 60 altogether. If I subtract it, negative 36 unit squared. And that is your answer. All right, let's take a look at I'm going to skip that one because I feel like we're already done enough with this one. You know what? I think we're pretty much good. Let's just go ahead and kind of jump into today's stuff. All right, so this is your breakdown for today. Our notes is going to be on integral using average value theorems. And we're also going to talk about integral using the second fundamental theorem of calculus, SFTC. Make sure you take a moment and go ahead and read your notes that I've typed up for the first 2 pages. So pause the video and go ahead and read them. And then go ahead and turn over to this page right here, where we're going to be practicing. Average Value Theorem MVT for integrals. All right, let's go ahead and take a look at this. Okay, if the function f is integratable on a closed interval a to b, then the average value of f on that integral is represented by, and just to make sense of it, so here is your function, y equals f of x. It's integratable on a closed interval between a to b. There's a point c in between there somewhere. Remember the MVT that we discussed. Before we talked about MVT, remember it was like a function like this. In between a to b, there must be a point c that's somewhere along the graph of a to b, where as a and b gets closer and closer and the limit becomes 0, their slope is equal to the slope of c. So the tangent line eventually, the secant line eventually gets closer and closer and it becomes the tangent line. So that's what MVT stood for when we talked about last semester. This semester is a little bit different because you do have integration. So then 1 minus b, 1 over b minus a, integral of a to b f of x dx. Just keep in mind that this is the upper bound. A is a lower bound. F of c is going to be representing the height. This entire thing here is going to represent the width. And here is the area. And if you think about it, since area equals height times width, you can go ahead and rewrite this several ways, just like back in trigonometry or where you rewrote the trig identities. The unit of height equals a over w. And you also know that width equals a over h. So just remember you can use them interchangeably. All right, example 1. Find the average value of f of x, x squared plus 1 on an integral of a to b, and then find the value c. Okay, so let's go ahead and rewrite this. F of x is equal to, or excuse me, not x, because it's going to be c now, is equal to 1 over, this is b, this is a, so 5 minus 2, integral 2 to 5, x squared plus 1 dx. Let's find the integration of that. So f of c is equal to 1 over 3. 2 plus 1 is a 3, divided by 3, you are going to get x over 3 cubed. Plus, integral of 1 is just an x. And when we evaluate that, because the integration is done, we already did that from 2 to 5. Okay, so 1 over 3, let's put in the upper bound and then subtract it from the lower bound, or the lower bound subtracted from the upper bound. So 5 goes in first. So then here I'm going to have 5 to the third power over 3 plus 5 minus, put the lower bound in, 2 cubed over 3 plus 2. Well, if you look at this, I know that 5 cubed is 125 divided by 3 plus 5 minus 2 to the third power is going to give me an 8 over 3 plus 2. So work your magic and see what that's going to give you. It's going to be something out of 3. So you will have to find the common denominator for all of them. And just be careful that there's a parenthesis there. Once you go ahead and do that, that should be equal to 126 over 3, which is going to be 14. So then 14 is equal to f of c, and that is your value for B. Oh, you know what? I'm sorry. That's part of the answer for not quite value for C. Just kidding. Sorry. Let's get rid of that. Kind of jumped the gun a little bit on that. So for part C, you have f of C is equal to 14. Okay. You also know that f of x is equal to x squared plus 1. So we're going to go ahead and set the two equal to each other. So x squared plus 1 equals 14. Subtract the 1 on both sides. X is equal to the square root plus or minus of 13. And that is your value for C for part B. All right, let's move on to the next part. Second fundamental theorems of calculus. Go ahead and just read this part right here. Take a look at the bottom part. And just remember, if I were to rewrite this, P of X is the upper bound, A is the lower bound, and that's equal to F of P of X times P prime. All right, let's do some practices using what you just went over. Okay, so just remember, you're gonna apply these concepts, the derivative and integrals. They are inverse operations of each other because you look at it, they're kind of flipped over. So for example 2, let's take a look at A. I'm gonna start off with something a little bit easy. So looking at this here, X is equal to P of X. And P of X here is equal to X. Equal to the F of P of X, which is just gonna be X squared plus 4 times what is going to be the derivative of P prime? Well, if P of X is equal to X, P prime of X is equal to 1. So times 1. And that's it. Your answer is just X squared plus 4. That's your answer. All right, let's go ahead and try example B. All right, looking at this part right here, you have X squared and then 3. So I know that P of X is equal to X squared. P prime is going to be 2X. So with this one, you have the square root of t minus 1. We're changing everything into x, so that's going to be a square root of x minus 1. And actually, you're going to have x squared because the top part is x squared minus 1 times, we're going to go ahead and put in the p prime, which is 2x. So 2x square root x squared minus 1. And if you're like, how did you get the x squared, Callahan? I'm not quite sure how you did that. Remember this part here. It's asking you to find the f of p of x. Well, if your p of x is equal to x squared, okay, and f of x is equal to the square root of t minus 1, then just remember, or I should say, there we go. Then when you go ahead and do the f of p of x, wherever there's a t, you're going to replace it with an x squared. So there's a t, I'm going to replace it with an x squared minus 1. Let's go on to C. All right, so for C, the p of x is equal to x squared, p prime equals 2x. So looking at this right here, I'm going to replace a t with the x squared minus 1, times p prime of x, which is just 2x. So my answer is 2x, x squared minus 1. All right, for D. Okay, so for D, you see that you have a 3x on the bottom and you have a 0 on top. You will have to go ahead and rewrite that so the smaller number is going to be on the bottom. So if I rewrite this, I am going to have just a negative because you're going to flip it. 0 to the 3x, 1 over t plus 2 dt, which is going to equal to, and remember, every time you see that there's a t, you're going to replace it with 3x, because remember, p of x is equal to 3x. P prime is going to be just 3. So I'm going to replace that as a negative 1 over 3x plus 2 times the p prime, which is going to be 3. So my answer is a negative 3 over 3x plus 2. All right, last one for E. For E, you have p of x is equal to x squared. So p prime of x is going to be 2x. So go ahead and plug that in and see what your answer will result in. Okay, so looking at this part here, we're going to go ahead and write this down. My pen is being a little glitchy. Here we go. All right, so I have my first part, which is replacing the t with the x squared. So 2x squared plus 3 times p prime, which is 2x. That's the upper bound. Minus, if I were to subtract it from the lower bound, I am going to get, replace the t with the x. So 2x plus 3 times the derivative. And remember, p of x is going to be equal to x. P prime for the lower bound is 1. Go ahead and distribute everything. You should have a 4x squared to the third plus 6x, minus 2x minus 3. So my answer is 4x to the third plus 4x minus 3. And that is your answer. All right, you guys. So I'm going to have you guys just take the rest of the class to go ahead and practice with this on the following assignments, which is right here. And as always, stay safe and healthy. Don't forget your math Excel for week 3. It's due on Sunday, and I'll see you guys next time. Take care.